Hey everybody. Thanks for sticking around for this amazing demo. My name is Nate Tabor. I'm joined by my colleague Elad Ben Israel. I work on the Kubernetes team at AWS. And Elad, I think you're on the call if you want to introduce yourself.
I'm the principal engineer for the AWS CDK. Hey guys.
Awesome. So we don't have a ton of time, so we're going to go ahead and just get rolling here. So today we're going to be talking about this awesome new project that we've been developing, and we just released an alpha called the Cloud Development Kit for Kubernetes, or the cdk8s. And the cdk8s is this project that we built based on the AWS CDK and all the innovation and technology that have gone there, which is an awesome open source project for AWS APIs. And what this does is it lets you write and generate YAML from familiar programming languages. And so what this does is you can write in languages like Python and TypeScript, and you can generate well-formatted Kubernetes YAML that runs on any cluster. And so we're super excited about this. It helps developers go from code to config really quickly. You can define applications and architectures using familiar programming languages. It lets you take best practices that you're sharing as files and templates and actually put them into code libraries that can be distributed and dynamically updated. And best of all, it runs everywhere. We've built it and it runs really great on AWS, but it runs actually on any Kubernetes cluster anywhere. And so Elad has a really awesome demo showing, I think, with Crossplane, right, Elad? And we're going to
Yeah,
actually show you guys how this works and how you can use this to configure your Kubernetes clusters and your Kubernetes applications. So I'm going to go ahead and stop sharing my screen and hand it over to you, Elad.
cool. Let me share my screen. Can you guys see it? Visual Studio Code.
Looks good.
Okay. So hey guys, nice to meet you. Thanks for having us. So as Nathan said, we just launched CDK8s in alpha this month, and it's a super early stage project. So we're super excited to hear from you, work with you, make it awesome. Like everything that you see here is just a first step. It is based on 3 years of experience we've had with the AWS CDK, which has a very, very similar problem space. And so we thought it would be interesting to try and take these technologies and tools that we built for the AWS CDK and apply them to the pure Kubernetes community. And so again, as Nathan said, this is not an AWS thing. This is an open source project. It's targeting any Kubernetes installation. Okay, so we'll do it really quickly because we don't have much time. And I really want to show you how to use Crossplane with cdk8s. I think there's some really interesting connections between these projects, and hearing all these panelists today, all those ideas are connected together in a really, really interesting way. So I hope you like it. So I'm starting here from an empty cdk8s project. I've created it using the cdk8 CLI. It's a very simple CLI, and one thing that you can do is initialize new projects. I just wanted to save some time. But this project basically has a single main function, main file. I'm using TypeScript. cdk8s currently supports Python and TypeScript, and there are other languages in the roadmap. Java, .NET, Go are definitely being worked on right now. cdk8s applications are structured as a tree of building blocks we call constructs. And constructs are a very, very powerful tool in the core technology, in a way, that we use for the AWS CDK as well. Constructs form this tree. And so at the root of the tree, you can see that I have an app. And then I can have any number of charts within that app. And then within that chart, I can define any other resources. And you'll also see that it's very, very easy to create your own constructs and then use them to compose together abstractions. The other command that you can see here is cdk8 synths. This basically is a command that synthesizes, takes the CDK application and synthesizes a Kubernetes YAML for each stack in your application. And so you see that I have this new file here, hello YAML, empty obviously because I don't have any resources. So let's start doing something, right? Like hello Kubernetes. It's always starting with a pod. And so, okay, I wanted to find a pod in my cdk8s application, and Kubernetes has 4 versions of pod throughout the history, and some people want to use this version of Kubernetes, and some other people want to use another version of Kubernetes. And so the Kubernetes API, one of the powerful things about it is that it's extensible, and it's basically an open surface area. So in order to allow you to use these resources in CDK, the CLI has this command called import, and this command basically takes in. Let me show you for a second. Oh, sorry. Oh, help. So this command can import Kubernetes API objects, but it can also import CRDs, and we'll very soon see how it imports CRDs. But let's start by importing the Kubernetes API, and as you can see, I can specify a specific version. And again, it's supported in all the programming languages that we support. Okay, I got a new file here under the imports directory called K8s. And so if I look at what's going on under this file, you'll see that I basically now have all the Kubernetes resources as strongly typed classes in my code. And those are one-to-one. Like you'll recognize all the Kubernetes API, right? Like replica sets and pods and whatever, stateful sets. The entire API is here as classes. And so let's start with a simple pod and see how that works. So we'll just create a new pod. And you see that when I create this pod, I have this signature for my constructor is always scope, name, and options. And you'll see this pattern come back in the construct programming model. I'll talk a little bit later about what this is, but basically you'll see that this is how constructs are being created and composed together. Okay, so now you see that my IDE can help me because this is all strongly typed. And okay, so I need to specify the spec. And then you can see that my IDE even tells me that I need to specify containers because containers is required. So I'm going to specify containers. And this is obviously very familiar to everybody here. So I'm just going to create a simple image coming from Alpine, a pod coming from, container coming from Alpine. And I'm going to use, sorry, let's do this. Cool. So I guess this is kind of like the minimum thing I need. Maybe I can do restart policy or something, whatever. I think this is fun. Okay, so now let's synthesize again. And when I synthesize again, I see my YAML now has my little pod. And the next thing I want to do with this is basically kubectl apply -f dist. And that would be our, kind of like deployment workflow. Okay, kubectl describe pod hello. Okay, looks like it started. And I'm using kind here, so it's very fast, very small. Okay, cool. So we've got our hello world. Let's do some interesting stuff. So let me delete this pod. I'm going to also delete it from here. And let's do some Crossplane stuff. But okay, so in order to do Crossplane, to define a Crossplane application, and I have Crossplane installed with my cluster, I need to, let's use the AWS provider. Okay, so I need to define a provider, and then I can define resources to connect to that provider. But in order to define a provider, I need the provider CRD somehow. And so I'd like to import this CRD into my cdk8s application. Now, I can use the CRDs on GitHub. I can use files. I can use whatever source of CRDs exists. I can also use CRDs just directly from the cluster. So you'll see here that I have all the Crossplane CRDs already installed in my cluster. And so what I will do is I'll basically do this. Just import all the CRDs. And you'll see that my CLI now created directories here for all the groups. So you can see all the nice CRDs that are bundled with Crossplane and the AWS provider added. And so it's all now here for me. And if I do something like, new Dynamo, Dynamo table, for example, you see that my IDE automatically helped me find it, and I can see that I have databases, blah blah blah. Okay, so let's start with the provider, right? New provider, and we have the Crossplane provider. Sorry, we have the AWS provider. Yeah, that's the one that I'm looking for. So this is my AWS provider, And you see, again, ID is helping me saying spec is required. That makes sense. And then region is required. That makes also sense. And then my secret. And okay, so I've installed my secret under AWS creds in the default namespace. I know that's not the getting started instructions, but it makes it easier to demo when it's all in the same namespace. Okay, so this is my little provider, and I can now do synth again and apply. And you see that my provider has been created for me, and obviously you also see that it's in my YAML file now. Okay, let's continue. Let's create a Dynamo table. So Dynamo table, and again I get my help here. So first thing I need is provider reference, and so the provider reference needs the name of the provider. And I want to stop here for a second and go back to my YAML file. You'll see that the name that I have for my provider is actually not AWS provider. It's a name that cdk8s created for me. And I could specify a name here. If you notice that I didn't specify metadata and name, and if I specified it, if I would have specified it, it would have been the name that I've specified. But one of the most powerful concepts of the CDK is this composition model. And one of the keys for this composition model is the ability to actually specify local names and not global names, or namespace global names in the Kubernetes space. And so what cdk8s is doing is basically it's generating a name from the path of this construct in my tree. And if this construct would have been deeper in the tree, you'd see that it would concatenate more elements in the path and add this little hash for me. But the result of this is that the actual name of the provider is something that I can obtain this way. And so this gives me the ability to maintain locality, which is a very important aspect of composition. Okay, second thing I need here is the provider. I even have like my little snippet here to make it a little faster. But basically, this is a Crossplane API for the Dynamo provider. And I just wanted to show you, like you can see that you have all the documentation, everything here is strongly typed. Even can do something like reclaim policy, and then it generates these enums for me that are also strongly typed with all the information. Okay, cool. So I've got my database. Let's do this again. And I can jump over to my console. And let's see if this actually did something. Tables. No table yet. Usually it takes it. Usually it's faster. Still. Let's see. See this provider. Okay, let's do kubectl. I think I can do describe, right? Describe Dynamo. Boom. Cannot describe table, request context deadline exceeded. Okay, let me try to delete it and recreate it. Provider ref. Do I need, no, I think this is fine, credentials. Okay, let's just synthesize this again and see if that might have worked. I'm not familiar with the trace. Dynamo table, nice. Daniel, do you have any idea?
I was just about to hop in here. I couldn't see exactly what was going on there with the context and seated. Will you try and cube control describe that dynamo table again?
Describe Dynamo.
This is one of our newer alpha resources here. So let's see. It looks like it hasn't been picked up yet. I would try to get the pods again in the Crossplane system.
This is a real live demo.
Okay, so it looks like your provider AWS controller is okay. You might try kube control logs of the provider AWS controller and see what that does for you.
Throttling request.
It could have to do with the amount that your cluster is able to handle right now. But this also, actually, I'm guessing that this has to do with this is going to be very in the weeds, but this has to do with a Go 1.14 bug that's a bug in kind, which we don't have to go through right now. But I think we got the main purpose here.
Okay,
And
no
so
worries.
that's
I'll
definitely not an
just
issue on
continue.
your end.
It worked really well actually prior to this. But let me just continue to show you a few things that I wanted to show you. So assume this is deployed, the table is created. The second thing I wanted to show you is, let's say I want to hit this Dynamo table using a pod. Okay, so I have my table. A table is pretty boring on its own, and so let's just create a pod here and call it Pinger. And what I'm going to do here, I'm going to create a pod, name, ping. And I'm going to create a pod that uses the Amazon AWS CLI image. And for command, what I'll do is I'm going to mount an entry point to my pods, which is a pretty common thing to do.
Awesome,
I'll do that from... Sorry,
I wanted
go ahead.
to jump back in here. I've gotten some backup here in the Crossplane Slack. It looks like your region on your provider is US East 1-1, which I don't think is valid. There we go.
Awesome. Team debugging.
Right.
Okay. Let's see. I wonder if I need to delete something, but let's try. Let's just give it a... I see the provider has been configured and the database is unchanged. kubectl get dynamo. Okay, this looks better. I think this is, there's hope. Ctl delete. Okay. Is this looking better?
Try and describe that one more time.
Okay.
All right. So we should see it coming there.
Okay, so we've got the database. Thank you. It was my mistake after, you see. Okay, let me continue with this pinger because I think it's going to be fun to see this. Okay, so I want my little I want to actually hit my database. So let's create a config map here. And again, as you can see, I have all the Kubernetes resources at my disposal. I'll call it entry point, and I'm going to use data, and then I'm going to do entry point.sh. And here I can just do this, right? So let's do AWS DynamoDB region US East 1 table name, put item, table name. And again, I need the name of my table, right? So I can just do this. So I can access it. And then the item itself, what I'm going to do, I'm going to use a little trick here to bring the item from two stringify operations. And it's just going to escape it correctly so I can actually. Okay, so my item has an ID attribute, and so I'm just going to put it hello here, and let's put the time so I can plug in the time from the script. And this would work because this is a bash script, so I can literally like use bash stuff here. Okay, so now I've got my little config map. Let's add a volume for it. Entry point, and it's coming from a config map with this name, CM name. And I'm going to mount it to mount path root. Okay, second thing I'm going to need is to mount the secret, right, the provider. So I'm going to actually do this, the credentials. And I'm going to take the secret from AWS creds. And I'm going to mount it to, this needs to be under the AWS directory. That's where the CLI looks for it. Okay, so, and by the way, the mistake that I did was actually a really stupid mistake because I can literally do something like this, right? I can do region, US East 1, and then basically use the same strongly typed reference everywhere and not make this mistake. Okay, let's see now. Okay, so I've got my pod created, kubectl logs, still creating, fair enough. Sorry. Okay, it's pulling the image. I think it's a pretty large image. So let's give it some time to create. But in the meantime, I want to talk to you just for a second about like creating higher level abstractions with constructs. And you guys talked a lot about higher level abstractions. Crossplane itself has these compositions, and CDK also tackles a similar problem with a different approach. The idea is that basically all these abstractions are created in the client. And so I can create an abstraction by basically just extending the construct base class. And then I'm going to give it the same signature as the classic signature. So let's just create an abstraction for my pinger. The only thing this pinger needs is the table name, right? Like which table it needs to ping. So I'm just going to pass it in as a third parameter. And before I'm continuing, okay, seems like this this worked. Let's see if this is actually did something. Obviously, it didn't work. Back to the logs. Oh man, all my tricks. What did I do wrong here? Root entry points in date. But this is not it. Bin bash. No, this is supposed to work, as always. Mm, okay, let's see if this, okay, yeah, using the wrong command. Okay, so date is a timestamp. Okay, so last thing I wanted to do, let's take all this stuff and refactor it. Okay, I'm going to take all this code and just put it under the pinger construct. And I actually need the region here as well because I've passed it over. So you see now I have table name and region as parameters. I'm going to also use the ID as so I'll know which pinger actually made the call. And now all I need to do is, in order to use this abstraction, is to create this pinger class. So I'm going to create a pinger class like this, and I'm going to need the table name and region. And I can actually do really cool things with imperative programming. All you YAML lovers. So I'm going to do something like this, right? I can create 10 fingers if I want. Let's see what this does. So this actually creates 10 fingers for me. And you can see that these guys are creating. Okay, they started to complete. And you'll see all my fingers talking to my database together. So yeah, this is what I had. I know it was really fast and super flaky. We'll upload this to GitHub if you guys are interested to look at this. And as I said, the project is super early stage. We'd love to collaborate with anyone who's interested to work with us on this.